One of the key challenges of looking at data at different scales and different resolutions is how do you bring that data together? How can you potentially compare it? The way I've approached this challenge is twofold, I suppose. One of which is to actually look at data at different scales side by side. So what I've been able to do is map my crime data up at different scales. So I've been able to map it to output area, to data zone, and also to grid, 100-metre grid. And this has been able to let me look at, does the relationships with the data, say if I'm looking at a chloropleth map of rates, for example. I mean, a system of mapping I use quite a lot is something that gets sometimes referred to as excess risk mapping, where I'll look at the data I'm looking at. How does this particular area here compare to the general average for the area? Is it above or below? And then you can colour up the map, so you might colour it sort of blue for below the area average, or red for above the area average. And I use that type of mapping. And what you can do is map that at different scales and say, okay, does it actually look different when I look at it at different scales? And I do a lot of exploratory spatial data analysis which looks at that. I use a package called Geoda, which is a free open source package, which enables me to do very quick exploratory spatial data analysis. And then I'll compare that, say, with data that's available only at the data zone level, say on population, and map my crime data that I've aggregated up to my data zone level alongside the data on population, and map them using a similar technique and compare those directly. Now, something like Geoda will allow you to brush and link. You can then also look at the data you have got smaller scale for the crime data and compare the differences. So that's one way of doing it. Something else I've looked at, although I'm not directly using, is the option of using multi-level modelling, where you can actually have your data at different scales. So there are various modelling techniques around where you can simultaneously look at your data at different scales. So that's another way of handling it. Also to repeat the analysis at different scales if the data is available at different scales, and see what that does. I haven't tried to, although there are techniques to do it. I haven't, in my work, looked at trying to split data at a coarser scale down to a more finer scale that's available. In my case, I think the margins of error would be unhelpful, and it hasn't been necessary for me to do that. So I suppose in my case, generally my work is involved looking at things at multiple scales and appreciating that there is actually something to be learned from looking at things at different scales, because in fact different relationships may occur at different levels, and so although the data sets don't entirely match, you can look at things at one level and then sort of compare it side by side with a finer detail and still get some information from that.